So last time we looked how to solve quadratic functions basically by seeing what x is. There is a reason that we're doing that, and it actually helps us in graphing those formulas and equations. So there's some terms that we need to talk about to kind of give you an idea. First off, I want you to understand that a quadratic equation with graph kind of can look like one of two possible ways. Well, there's different versions of it, but generally you have something that looks like this, okay? Or you might have something that looks like this. Now, I will tell you that that shape can be the overall shape is like an N, and this overall shape could be like a U, but it can be skinny, long, tall, fat. It could be down here, up there, anywhere on the graph. But the main point is that it's either going to be in this type of shape or this type of shape. So that's kind of what you need to understand about a quadratic equation. With graph, it looks like either a U or an upside down U, if you want to say it like that. Alright, so first term that I want you to know is what they call axis of symmetry. It's basically a line that splits the graph down the middle. Okay? So it's a line that splits the graph down the middle. That's really all the axis of symmetry is. And the way we solve for that is this. X is equal to negative b over 2a. Alright? So this might look somewhat familiar. It's very reminiscent of the quadratic formula that we taught in the last module. So if I know what the equation is, I can find the equation for this line. Alright, it's the same thing on this one, okay? I could find the middle of this by using that same equation. Alright, so the vertex is simply this. It's either the highest or the lowest point of the graph. Like this part right here is the highest part of this graph. That's my vertex. This point right here is the lowest point of this graph. But that's my vertex. So vertex is either the highest or the lowest point of the graph, depending on the graph. Now, the question is, how do we find the vertex? Well, it's simply, the way we kind of write this fancifully is this. Negative b over 2a, comma, f of negative b over 2a. This is the fancy version. Basically, it's a set of ordered pairs where the first ordered pair is this point on the axis, and whatever point lines up the y. Okay, let's make that a whole lot easier. Whatever number you get here, you're going to basically plug back into the original equation. So, plug negative b over 2a back into the equation. That's all you're doing. Alright, so y-intercepts. Y-intercept is where it crosses the y-axis. So like on this guy, it crosses here. That's my y-intercept. Same thing on here. Here's my y-intercept. And it's found by plugging 0 into x in the original equation. So wherever there's x, put 0 in the place of it and solve for y. And you have your y-intercept. The last thing, next to the last thing is the X-intercept. It's wherever the graph crosses the x-axis. So we have a point there and a point there. So this graph crosses the x-axis at these 2 points. And the same thing can be said for this one. Now, what do we do? Basically, it's found by 2 ways. 1, quadratic formula, and 2, factoring the equation. That's what we did in the last video. So all those times we've been solving for x, that's really what we were doing, was finding where the graph crossed the x-axis. That's why I made you do all those equations. And then finally we have the opening. Well, think this through. Alright, I have it opening. How is it opening? Notice I'm drawing arrows. It's opening in a downward direction. Where this one is opening up. Okay? So think of it like this. This guy, the graph is constantly going down. It never stops. It keeps going down to infinity. The other guy is constantly saying this direction, always to infinity. All right, so what we're getting ready to do is I'm only going to do 3 problems with you, okay, on the board, because just one problem is going to take some time, because we have to find the axis of symmetry, we have to find the vertex, we have to find the Y-intercepts, and we have to find the X-intercepts, and we kind of got to know how it's opening. So we're going to do 3 problems, and that's as far as we're going to take this video. I am going to show you something else on the computer, but we'll get to that a little bit later on. So let's go ahead and get to the first problem. Alright, I was first going to do the work here on the board, but I decided I was going to use the dot cam instead. I think it might be a little bit easier for you to see. So in this problem, I'm asking you to graph f of x equals x squared plus 4x plus 4. Now, okay, you're probably asking yourself, well, this is weird. Look, guys, f of x, I've told you before, is the same thing as saying y equals x squared plus 4x plus 4. It's the same thing, okay? So really f of x is the same thing as y. So nothing's really changing here. Alright, so let's just go ahead on to it. One of the first things that, really the best thing when you go to graph an equation, one, yes, we can use this, but we're not, the best thing is to find the axis of symmetry. Alright, so our axis of symmetry, we're just going to say AOS. Alright, that's too light. Let's go ahead and use an actual pen. Alright, so we're going to say, hey, here we go, black. The axis of symmetry, and I told you to find that, it's x is equal to negative b over 2a. Alright, so we're just going to plug in our numbers. We know that 4 is our b, so we know that x is equal to negative 4, which is here, okay, that's our b, over 2 times 1. Well, whilst that solve all this out, and I get that my x is equal to negative 2. Alright, so our axis of symmetry is negative 2. And I am going to circle this so that when I need it, we have it. So here is our axis of symmetry. Alright, now, after axis of symmetry, we need to find the vertex. Well, in order to find the vertex, basically, we're going to take this negative 2 and plug back into this original equation. So let's do that, and I'm going to use my handy dandy calculator on this because I feel mighty lazy, and I'm going to say negative 2, and I'm going to store that as my x. Alright, so now let's just go ahead and plug everything in, and we're going to say x squared plus 4x plus 4. And what do we get? We get that y is 0, so our vertex is going to be negative 2, 0. That's our point that we're going to plot. And if you didn't want to be lazy and you wanted to put it in, we can do it. Alright, so negative 2 squared, well, what's that give me? That is going to give me a positive 4. 4 times negative 2 is negative 8, so 4 plus negative 8 is going to give me negative 4, plus 4 again gives me my 0. Alright, so that's the other way. Alright, so now we need to locate our Y-intercepts. The Y-intercepts, like I said, is basically where it crosses the Y-axis. And how do we do that? We simply basically say this: everywhere there's an x, we're going to plug in 0. So that's going to be 0 squared plus 4 times 0 plus 4. So ultimately we know that f of 0 is equal to 4. So our Y-intercept in this case happens to only be 1, and we get that our Y-intercept is simply 0, 4. So there's our Y-intercept. And I'm going to circle that one. We're going to circle that one for our vertex. The last thing that we need to know is our X-intercept. Well, our X-intercept, I told you that it was 2 ways that we can find it. One, we can take the original equation and we could either A, factor it out, or B, use quadratic formula. Well, I'm looking at this equation right now, and let's just go ahead and rewrite it down here. I don't feel like writing intercept all the way. And we have this equation. f of x is equal to x squared plus 4x plus 4. And what we're going to do is we're going to set this equal to 0. 0 equals x squared plus 4x plus 4. Now this is very reminiscent of what we did in the very first video of this particular module series. So what are we going to do? We're going to solve for x. Well, look at it. Let's do this easy. What does this look like? It looks like the square of sums. It looks like a special product, and it is. So we can simply say that 0 is equal to x plus 2 times x plus 2. Alright, what's that tell me? Well, x plus 2 is equal to 0, x plus 2 is equal to 0, so x is equal to negative 2, and x is equal to negative 2. But wait a minute, this is weird. Everything I've given you up until this point, I've had two different x's. I've got the same x. Hey, that's okay, it happens. Sometimes you only get one intercept. So really, instead of getting two intercepts, I only have one. So my intercept for this particular case is going to be negative 2 and 0. Well, I don't know about you, but that looks mighty familiar, and it should to you too, because it's the same thing as our vertex. That's kind of interesting. Well, we'll talk about that in just a minute. So we have just found out everything we need to know. First off, we found that our axis of symmetry is at x equals negative 2. Our vertex is negative 2, 0. Our y-intercept is just at 0, 4. It only crosses the y-axis one time, so technically I should say just t-intercept, not intercepts. Alright, and then the x-intercept is negative 2, 0. So what we're going to do is we're going to take all that information that we just did and we're going to plot it. Alright, so first off, it says that our axis of symmetry is at x equals negative 2. So here's negative 2, and my axis of symmetry, I'm going to kind of draw this one with a pencil, because generally speaking, we don't include this in the final graph. But what it does is it helps us understand that this axis point is basically kind of like a mirror line. So whatever's on this point, on this side over here of my graph, is identical to this side over here. So basically think of it like a mirror, because it's splitting it down the middle. So now that we've got our axis of symmetry, we need to plot our vertex. And the vertex is at negative 2, 0. So I'm going to use a color now. And we're going to say negative 2, 0 is right there. Okay? The next part says that the y-intercept is at 0, 4. So it's going to be right here. Okay, and now we look at the x-intercept, and it only tells us that it's going to be at negative 2 and 0. So basically I've done everything I can currently do in graphing this. So how do I finish graphing this guy? Well, remember what I just told you, that the axis of symmetry acts as a mirror? Okay, so whatever I plotted on one side, it mirrors on the other side. So notice where this one is. I'm going to find that exact same point over here and mirror it and see how it's at equal distance from one another. So knowing this, I can actually kind of sketch a very rough graph of this. And here's the cool part. It doesn't have to be exact. All right? This right now, when we're sketching on paper, is literally a rough draft, and that's all you have to do for on paper. Okay, that's it. So your graph, when plotted, is going to look very similar to this. Now it might be slightly different, it might stretch out a different way, or it might go in a little bit different way, but ultimately you have this, and it means that last thing is that it opens up. Alright, so don't believe me? Let's find out. Go to your y equals and plot that in, x squared plus 4x plus 4, and graph it, and what do you see? It's basically the same thing that I graphed right here. Okay, this is my intercept, x-intercept of negative 2 and 0. This is my y-intercept of 0 and 4. Alright, so this right here, even though it's slightly different than my graph, it's still the same thing. Alright, so let's go to the next problem. Oh, before I go to the next problem, you may be asking, it's like, I want to just kind of reiterate this. You don't always have to have two x-intercepts. In this case, we only have one. Sometimes you have none, at all. So it depends on the equation itself. So just because you get something that doesn't make sense, you can always go back and look at the actual graph in your calculator to see if your work matches. So now let's go to the next problem. Alright, so here we go. We're going to graph this equation, x squared minus 2x minus 6. So we're going to do the same thing. The first step that I want to do is I want to find my axis of symmetry. Alright, and to find that, we know that it's going to be x is equal to negative b over 2a. So x is equal to negative b, which happens to be negative 2 in this particular problem, over 2 times 1. Well, this gives me x is equal to 2 over 2, so x is just equal to 1. So my axis of symmetry is x equals 1. Alright, so now that we know that, we need to talk about our vertex. Basically, we're going to plug 1 back into our equation. So we can do this manually or we can do it in a calculator. This time, let's do it by calculator again. I am going to say 1 and I'm going to store it. Okay, so I don't feel like having to do all the math. Now I'm going to say x squared minus 2x minus 6. And that tells me that my vertex is at 1 and negative 7. Now, don't believe me? Do it the real way. Put 1 into place of this. 1 squared is 1. Minus 2 gives me negative 1 minus 2 gives me negative 1, minus 6 again gives me negative 7. So that's my vertex. The next thing that we need to know is our y-intercept. How do we find it? We basically put 0 in the place of all our x's, and so what happens, I'm going to just put y-intercept like that. We can do this. Y is equal to 0 squared minus 2 times 0 minus 6. Or simply, y is equal to negative 6. Therefore, our y-intercept is 0, negative 6. Alright, so there's our y-intercept. Sorry, I didn't realize I went off paper. So we plug in 0 in the place of x, solve for y, and we find out that our y-intercept is at 0, negative 6. Now we got to do our x-intercept. Alright, so x-intercept is usually always the toughest because there's two ways of doing it. One, we have to either A, use quadratic formula, or B, we have to factor it. So let's look at the original equation. I'm going to write it down here. And we have, the original equation is y is equal to x squared minus 2x minus 6. Now, just looking at it, I know that there are no factors of negative 6 that's going to get me to a negative 2. But when added together, negative 2. So I'm going to have to use the quadratic formula. So let's do it. We're going to say negative b plus or minus square root b squared minus 4ac all over 2a. Alright, see what we did? We made sure that we put everything in the proper spot with our quadratic formula. Let me finish that right all out. Now let's go ahead and do the work. So we know that this is going to become a 2 plus or minus. Well, this is going to give me square root of 4 minus 24, I believe. Nope, that's going to be 4 plus 24. Let's double check. Negative 4 times 1 times negative 6 gives me, whoa, that didn't work. 4 times negative 4 times 1 times negative 6. Just double checking. Yes, it's going to give me a plus 24 all over 2. Alright, so I'm running out of room. I'm going to come up to this top here. Okay, and we're going to say that it's 2 plus or minus the square root of 28 divided by 2. This can give me 2 plus or minus, and I think we can factor, let's see what we can factor out. 28, can we factor out a 4 in this? Yes, we can. So we can say 2 plus or minus the square root of 7 divided by 2. Or ultimately, x is going to be equal to this. X can be equal to 1 plus the square root of 7, and x can be equal to 1 minus the square root of 7. Not 3, 7. So what we have to do before, let me rewrite this. 1 minus the square root of 7. Okay? So before we do anything else, we need to double check this into our equation and see if it works. Alright? So, if it works, it means that when we plug in whatever these numbers are back into this, our y should be 0. So let's go ahead and do that. We're going to say 1 plus the square root of 7, and we're going to store that number. And now we're going to plug it in. We're going to say x squared minus 2x minus 6. And since we were setting this equation out to 0 to find our x, this should equal to 0. And it does. So now let's try, so that tells us that this works. Now let's try the next one. And we have 1 minus the square root of 7. We have this number, we're going to store it, and we're going to plug it back into the original equation by saying x squared minus 2x minus 6. And if this one works, if this number works, it should also equal to 0. And it does. So, what did we just discover? And sorry that I'm running out of room. I discovered that I have two, count them, two X-intercepts. And they are this. They are, and I'm going to write it the easy way because I'm running out of room. My X-intercepts happen to be 1 plus or minus the square root of 7 and 0. This is a shorthand of writing it. Instead of saying 1 plus the square root of 7 and 0 and then writing another ordered pair that says 1 minus the square root of 7 and 0, I can just combine it all together in one nice lump, and it's a whole lot easier to write on paper, especially when you're running out of room. So, going back over this thing, we know our axis of symmetry to be x is equal to 1. We know that our vertex is at 1, negative 7. We know that our y-intercept is at 0, negative 6. And we know that we have two, count them, two x-intercepts, 1 plus or minus square root of 7 and 0. So now what do? We're going to plug all this stuff in. So the first thing, let's find our axis of symmetry. Alright, and it happens to be 1, so we're going to go ahead and say it's about here. Okay, and again, I'm drawing it in pencil because really we really don't need it in our final product, but it's really good when we're trying to draw it because of it's whatever you draw on one side, you can mirror on the other. Alright, so the vertex happens to be 1 and negative 7. Well, let's go ahead and use our color, and that's going to be approximately here. Alright, and let me scoop this up so you can see. So I've got my axis of symmetry, there's 1 and negative 7. Now we're going to find our y-intercept, which happens to be at 0 and negative 6. And now we have to plot our x-intercepts. Well, this is where it gets a little bit confusing. So let's plot the first one. We're going to say 1 plus the square root of 7. So we're going to plot that one first. And what we do is we find out what it's equal to. And it's equal to like 3.6 blah, 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 blah. So we're going to make an estimate on our graph where 3.6 blah, blah, blah is located on our paper. So here is 3 right here. So I'm going to make an estimate to right about there. I think that's good. So that's my first x-intercept, and that's the 1. I'll write it over here. This is actually the 1 plus the square root of 7. So that was, and 0. So that was my first x-intercept right there. So let's find our second x-intercept by saying 1 minus the square root of 7. And this one, it says I have a negative 1.6 blah blah blah. So we're going to try to find it. We know negative 1 to be here, so I am going to kind of guess that this part right here is going to be our 1 minus the square root of 7 and 0. So those are our points. We know here are my x-intercepts, this is my y-intercept, and this right here is my vertex. Now what's really good is if we want to kind of keep this symmetrical, we can kind of say that if wherever this point is, we can kind of plot its mirror point over here. And I would say it's about, looks like right about here. Okay, so now I have just enough points where I can actually plot my graph. And again, this does not have to be perfect. This is just a rough sketch. And we're going to line up all our points. And there we go. All right, so, and that's our parabola. Okay, that is our graph. All right, we found our axis of symmetry, we found our Y-intercepts, found our X-intercepts, and we found our vertex. And knowing all these things, we can kind of get a rough sketch. So let's see if it's correct by plugging the actual equation in. So we can say x squared minus 2x minus 6 into our graphing calculator. Hit graph, and let's kind of check it out. Hey, not too bad. It's about the same thing. Ours is just a little off because, hey, I got some wonky handwriting and everything, but it matches very well. And the other thing that we can say about this graph is that it opens up. All right, let's do the last one. And we're almost through, guys, almost through. All right, so we're going to do the same thing again, and this is the last problem that I'm going to work with you because all this is pretty much redundant. So again, first step, find our axis of symmetry. So we're going to find that x is equal to negative b over 2a. That means that x is equal to negative times negative 4 over 2 times 3. That gives me a positive 4. X is equal to positive 4 over 6, or x is equal to 2/3. Let's just double check our math on that. Negative b over 2a, that's going to be a negative 4. Divide by 2 times 3, that's positive 4 divided by 6, 2/3. All right, very good. So we know our axis of symmetry to be 2/3. Now we need to find the vertex. Basically what we're going to do is plug 2/3 back into our equation to find out the vertex. We can do this manually, but again, I am going to be lazy in here, and we're going to say 2 divided by 3, and we're going to store that number as our x value. And now we're going to plug it in. We're going to say 3x squared minus 4x plus 5. All right, and that tells me 3.666. Basically, this is 3 2/3. And let's just go ahead and frac it and say our fraction is really, in this case, our value is going to be 2/3 and 11/3. So that is our vertex, 2/3 and 11/3. All right, now we need to do our Y-intercept. And that's the next easy one. We basically plug in 0 in the place of things. So y is equal to 3 times 0 squared minus 4 times 0 plus 5. Therefore, y equals 5. So our y-intercept is 0, 5. Now, you have probably figured out something. This last term is really what the y-intercept is. If you've got it written out in this format where it's ax squared plus bx plus c, c is always going to be your y-intercept. So technically, there's really no reason to even do all this. You could just write whatever c is. And that's just a little shortcut. All right, so our y-intercept is a 0, 5. All right, so circle that. Circle vertex 2. Alright, and the last thing happens to be our X-intercept. Alright, so we have the equation, let's write this out. Y equals 3x squared minus 4x plus 5. Alright, so I could probably try to factor this out, but this time I don't want to again, so I think it's going to be easier just to go ahead and use the quadratic formula. So let's sing our song. Negative b, plus or minus square root, b squared minus 4ac all over 2a. All over 2a. So let's double check. Negative b plus or minus square root 4b squared minus 4ac all over 2a. So we've got everything written out what we need. And this is for our X-intercept. And let's go ahead and work this rest of, wow. This is 4 plus or minus the square root of 16. This says 4 times 3 times 5. Making sure there was no negatives I didn't miss. So 4 times 5 is 20 times 3 is 60. So minus 60. All right, all over 6. All right, so let's keep going trucking. I'm running out of room, so I'm going to kind of finish this up. 4 plus or minus the square root of 16 minus 60 equals negative 44 over 6. Now, I am going to stop right here. Let's go back all the way back to our first set of videos. I gave you something that said the square root of negative 44 here. Look at this number. There's something that I talked about all the way back at the beginning of the semester, and let's see if you can remember it. If I were to take the square root of negative 44 right now and hit enter, look at what happens. It says non-real answer. So what does this mean? It means that this number is an imaginary number, and like I said, we're going to be talking about it later on. Actually, we'll be talking about it this module. We're almost to it now. But you know what this means? It simply means there is no X-intercepts. Again, why is that? Because this has a square root of a negative number. It's an imaginary number. It does not exist. Therefore, this right here doesn't exist. It's imaginary. So what is it telling me? That when I graph this equation, there is not going to be any X-intercept whatsoever. Woo! So that might be a little bit of a problem. Well, we'll see. Alright, so let's go through this. We found out that our axis of symmetry is 2/3, x equals 2/3, our vertex is 2/3 and 11/3, our y-intercept is at 0,5, and that we have no x-intercept. So let's use this information to graph it. So our x-axis, I'm running out of space, there we go. Our x-axis is 2/3, well that's 0.6666 infinity, and we know that right here is 1, so I'm going to say approximately right about here. Okay, so there's my axis of symmetry. Again, we won't need this in the final product, it's just good to have as we're graphing, because whatever we do on one side, we can mirror on the other. Now, our vertex is 2/3 and negative 11/3. Well, this, in case you don't know your fractions, 11/3 is equal to 3.6 infinity. All right, so we need to find that. 3.6 infinity, well, here's 3 right here, and so I would say that 3.6 infinity or 11/3 is right there. So I'm going to plot that point, and we're just going to kind of write that down as our vertex. So just kind of so we don't get confused on what things are. There's my vertex point right there. Okay, so 2/3 and 11/3, and you might not be able to read that. Make it darker. All right, now the y-intercept says 0, 5. So 0 and 5 happen to be right here. So as of now, I only have 2 points on this graph. I have this point and I have that point. Okay, because there is no x-intercept. So what does that mean? Well, in order for me to finish graphing this, I need to remember whatever I can do on one side, I can mirror on the other. So I'm going to mirror this point right here directly to the other side. So I'm going to say approximately right about there. That's a good estimate, and that's pretty close to being equal distance apart. And really, this is all I've got. And so I'm kind of going to do my graph kind of like this. And that's it. Notice that this graph never even came close to the x-axis. That's how come we know there's no x-intercept. Don't believe me? Well, let's plug this back into the equation, into our calculator, excuse me, and see what happens. 3x squared minus 4x plus 5. Hit graph. And there we go. And it's slightly off right here. And notice how our graph doesn't cross the X-intercept. So I've shown you 3 unique problems that I really wanted you to kind of pay attention to. The first one you have 2 X-intercepts. The second one you have only 1 X-intercept. And then the last one you didn't even have an X-intercept at all. So be very careful of that. Now, the only other thing that I did not really show you in this, and I think you'll understand it, is that not every graph I'm going to give you is going to be a positive this type of shape opens up. I will tell you this as a hint. If I were to give you, and just kind of graph this out, this is free information, you don't have this in your notes. Here we go. If I were to give you something like this, negative 3x squared plus 4x plus 5, now I just made that up. It doesn't really matter. When I go to graph it, it's actually going to be opening down. How do we know this? It's because of this guy, this very first coefficient. If it is a negative coefficient, if it's a negative, it opens down. And if it's a positive, it opens up. Okay, so that's just a little free piece of information for you. Again, it's not in your notes, but it can give you a hint on later on in your stuff. All right, so I'm almost done. What I want to do now, and it won't take us but just a few moments, I'm going to show you how to answer a few questions on the computer. All right, so I've given you an equation, and you are supposed to identify all this stuff and graph it. So first off, I don't know why they do this. The first thing for you to do is to find the axis of symmetry, then the vertex. But anyway, you found the vertex to be 1, 7. You found your axis of symmetry as x is equal to 1. Notice I said x is equal to 1 and not just 1. This is an actual line. It's a vertical line. So if you just tell me the axis of symmetry is 1, that's not correct. The axis of symmetry is x equals 1. All right. You found out the y-intercept is at 0, 4. Then you tell me the x-intercepts are these really long things. And hey, that happens sometimes. But you checked your answer and you know you're correct. And when you put it in the computer here, it said, hey, you're right. And which way does the parabola open? You didn't even have to graph the graph because this thing says negative 3, and just like I told you a while ago, if this first coefficient is negative, it automatically opens downward. The last step is to graph it, so let's graph it. What you need to do is, you see this one right here is the U, and it's got 2 dots. It says vertical parabola tool. Click it. And now you got a little doodad here that's kind of going around your screen, whatever. So it tells you in the little yellow box, and I'm pointing with my finger right now, guys, like, here, look at the yellow box, and then I realized, hey, you can't see my finger. But anyway, it tells you in the yellow box to plot the vertex of your parabola. So we need to plot the vertex, which is 1 and 7. So there we go. There's our vertex. Now it just says to plot a point on the parabola. Well, it doesn't really matter, but I would plot the y-intercept. In this case, the y-intercept is 0, 4, so we come down to 0 and 4, click it, and this should be our answer, so we'll hit save. All right, check answer. Good job. We did really good. All right, so that's really how that works. I wanted you to see it. Seeing if I could do something else. Oh, here we go. This is another one real quick. I can graph this fairly quickly. Again, I'm not going to solve this, but let's just say we found out that the vertex is at, I don't know, negative 2 and 3. There's my vertex, and we found out the y-intercept happened to be 0 and negative 1. There's my graph. So that's what I wanted you to see. Do your vertex first and then plot your y-intercept, and you have your graph in your homework questions. And that's it, guys. This video is now complete. You got just a few more to watch, and we are almost done. See you next time.